Okay, so a very good morning to all. Myself Nazim Ali Chinwala. I am research scholar working under the guidance of Dr. C.H. Solanki sir at SVNIT Surat, and on behalf of Indian Geotechnical Society Surat Chapter in association with Indian Geotechnical Society Student Chapter of SVNIT, I welcome all the dignitaries and participants for the webinar lecture on applications of geosynthetics in civil engineering projects by Dr. Anand M. Hulagabali. So quickly, I'll read out the resume of Dr. Anand Hulagabali, and then we'll start with the session. So Dr. Anand M. Hulagabali received his bachelor degree from KLES College of Engineering, Belgaum, MTech and PhD from NIT Surat under the guidance of Dr. C.H. Solanki. His primary research interests are reinforced earth structures and geosynthetics, CFD applications in environmental geotechnics, ground improvement techniques, computational geomechanics, and deep foundations. Other than research, he is actively involved in departmental consultancy work. Before joining NIE Mysuru, he worked at Embo University, Ethiopia, East Africa for a couple of years under the UNDP program. During his stay at Ethiopia, he worked as a visiting faculty for 5 premier universities of Ethiopia. He also worked at Basaveshwar Engineering College, Bagalkot for 3 years. He obtained few years of research experience from IIT Madras under the supervision of Dr. G.R. Dodagodar. He has published around 45 articles, including book chapters, peer-reviewed journals, and conference proceedings. He has guided 25 postgraduate students and attended more than 60 conferences, SCTP seminars all around India and abroad. He has delivered many technical talks at different engineering colleges of India. He is also a reviewer and editorial board member for 5-year review journals and member of many prestigious professional bodies such as ASC, IGS, ISSMGE, IST, and IEI. So with this short biodata, I would like to call upon Dr. Anand Hulagabali to share his expertise with the participants. Thank you.
Thank you, Nazim. Am I audible, Nazim?
Yes, you are audible.
Okay. Good morning, everyone. I thank Indian Geotechnical Society Surat Chapter and its office bearers, Professor C.H. Solanki sir, Nehal Bhai, and Hitesh sir, for giving me this opportunity, and the office bearers of Indian Geotechnical Society Student Chapter of SVNIT Surat, Najim Ali, and all my dear friends, Mohit and Manali, Bhumi, and also Bhavita madam. This is an immense pleasure for me because being an alma mater of SVNIT Surat for my both PhD and MTech, it's an immense pleasure for me to give a lecture on geosynthetics in civil engineering projects. So without wasting much of our time, so I'll just start with sure. Okay. Yeah, Nazim, is it visible?
Yes.
Okay. So we are going to talk about applications of geosynthetics in civil engineering projects. Since this has been my primary area of interest, so we have done a lot of work in this area, and a few things I'll be discussing in this particular webinar. Before I go with the actual applications of geosynthetics, first I thought that we need to first understand why geosynthetics are needed, why it is so important, and the concept behind this geosynthetics, which is basically a reinforced earth concept. So we'll look into some historical development and the background of reinforced earth, and some mechanism of reinforced earth. Coming to the geosynthetics, types, functions, applications, advantages, and case histories. At the end of this lecture, I'll be discussing about few case histories where geosynthetics has been deployed successfully in various sectors of civil engineering. Uh, First thing is why we need geosynthetics. Okay, so there are different problems what we are facing in today's life. Okay, so one is all of you know that due to the heavy rainfall in recent days, in fact, every year it has become a huge problem. So landslides has become a big challenge for us. Okay, so we can call it like a slope failures or maybe a landslide. So these things are due to the heavy rainfall or maybe due to the small shocks or from the earthquakes or maybe due to some increase in pore water pressure by the rainfall or something like that. But when we are dealing with this type of slope failures, we need to understand the basic background of these slope failures, and we need to deploy some method where these landslides can be mitigated successfully. Okay. So these are some landslides which occurred very recently. Like you can just see that a couple of days back in near Belgaum, Karnataka, in Dudhsagar, there was a landslide. Because of that, they have stopped the railway, functioning for a few days. And even in fact, last year we have seen many landslides near Western Ghats, even in some parts of Kurg district in Karnataka in last year and two couple of years back. So what we are seeing is like, from last 2 to 3 years, there has been a lot of rainfall, and due to that, we are experiencing a lot of problems with respect to the landslides. Okay, so these are some landslides which occurred. In fact, just 3 days back, there was a landslide in Bangalore-Mangalore highway. So, in fact, it was also some section of the highway was closed due to the landslide. It's not only about the landslide, so we have problem of different failures with respect to the canals. Okay, so for example, you can see some of the images here where the subsidence has occurred in the canal liners due to the defects in the lining, and we have something called as chiseled embankment, where the small section of the embankment or the small section of the canal has been completely vanished, and where it is due to the high current of water. Okay, and maybe due to the internal stresses which are going to occur, that may cause the complete collapse of canal liners along with the whole section of the canals. Then, in fact, we have also seen some earthen dam failures in recent years. One earthen dam failure, which was very, very significant, was in the Konkan region of Maharashtra, where almost 19 deaths were occurred, and also 4 people were missing, uh, as per the records of the newspaper. So we can see that it was a very old, in fact, earthen dam, and due to that, due to the heavy rainfall. So all of us, as we know that in Western Ghats, rainfall is a big factor, especially in monsoon seasons. So due to the heavy rainfall, so there has been a collapse of earthen dam. Okay, so in fact, even in US also, there was one failure of earthen dam, you know, uh, which was mentioned in the article of Sharma RP et al. In 2013. And coming to the failures of pavement, okay, it's not only about the earthen dams or canals or landslides. So even in fact, we have seen a lot of problems with respect to the pavement. Okay, so surface of the pavement has been deteriorated due to the so many reasons. We can see that a lot of longitudinal cracks. Then we have the agitator cracks on the surface of the pavement. In fact, We can also see that there has been a lot of potholes formation here, and the rut formation is there. So these all things are due to the um, probably due to the subgrade soil, which is expansive in nature, and maybe due to the infiltration of the water from the surrounding of the pavement, which can cause such failures. Okay, so we need to deal with subgrade soil very effectively so that we can avoid these type of failures. Coming to the area of geo-environmental engineering, where the landfills are big problem for us, where the open dumps what most of the cities they follow. Okay, so when we have the open dumps, then there is a problem of rodents, and also there is a problem of leachate which is going to come from the landfill, and that leachate is going to contaminate the groundwaters, and if we pump the groundwater, then it becomes a huge problems for different diseases. But so we need to deal with this the disposal of municipal solid waste very effectively. And in recent year in recent years, many of the researchers have worked they have worked enormously in the field of geoenvironmental engineering, especially in the disposal of municipal solid waste using the engineered landfills, where we have the usage of geosynthetic products in so many different areas of landfills. So this is also one of the huge uh, challenge for all of us. Even in Mysuru, we have the problem of open dumps, even though it's one of the cleanest city in India under the population of 10 lakhs. But you know um, we are not following this engineered landfill, so we are just following the open dumps, where it has to be solved as soon as possible. Coming to the failures of retaining walls, again, we have seen a lot of failures with respect to the conventional retaining walls, where the failure may be due to the overturning or maybe due to the lateral sliding. But when we see the different failures, we can actually understand that, okay, something innovative ideas are required in this, and something has to be done so that we can have better stability in these kind of structures. Okay, so there we are going to incorporate the different geosynthetic products, by which we can actually increase the stability of these retaining walls. In fact, coming to the shore failures, okay, so we have seen a lot of cases where due to the continuous erosion of soil or erosion of sandy soil near the seashore. You can just look at this image where a lot of edges have been cut down due to the continuous flow of water. And and these tides are always coming with a lot of higher velocities, and these waves will try to take out a lot of soil particles with them. So that's the reason we see such type of failures, uh, especially in the seashores. In fact, during my masters, so we were fortunate to visit one of the place here near Surat, so Tithal, where the Gabion walls have been huh?
There is a power cut, so he is going to join in a while. Kindly bear with us.
Hello, hello.
Yes, Anand, audible.
Okay, sorry. Actually, there was a power cut, and due to that, my Wi-Fi went off. Okay, so I'll just continue. Okay, so this is what we were actually discussing. So this is like, one case study we have seen during, in 2012, we were fortunate enough to visit one of the Swaminarayan temple in Tithal, where, ABN walls were deployed successfully, to protect the shores. So those are a few examples of applications. And even in fact, we have seen a lot of failures of runways. Okay, so the runway surfaces have been failed due to the slippage, due to the slippage failure, due to the loss of bonding from the surface. And also we have also seen a lot of potholes which have been formed on the runway surfaces, maybe due to the disintegration of the top surface. So one case study you can see here, how the disintegration has occurred from the top surface. So this has been taken from the case study of the airport in Philippines, and this is one case study of airport in Japan. Okay, uh, coming to the you know Nazim, I think you can mute yourself. Okay. Okay, then coming to the background and historical background of and historical development of reinforced earth, because when we look at all these failures, we need to have some sustainable solution where we can easily, use that solution, and we can try to implement that very effectively. So that's very, very important. So now, if you look at the background and historical development of the reinforced earth. So geosynthetics are based on this particular concept. So we need to understand what is reinforced earth. So that concept is being, implied and being used for the geosynthetic products. So now coming to the reinforced earth, what exactly is a reinforced earth? One thing is, just like reinforced cement concrete, we have we have a concept called reinforced earth. So when we insert some reinforcements in the soil, then we call it as a reinforced earth concept. So similarly, how we insert the reinforcements or the steels in the concrete. So similarly, we are going to insert some natural fibers or natural products, or maybe man-made products like polypropylene or polyethylene products in the soil, which are basically called as geosynthetics, and we call it as a reinforced earth concept. So it's not a new technique basically. Many people have already used, especially our ancestors in the rural areas, they have used this particular technique very effectively, but it was technically patented by Mr. Henry Vidal, who is a French architect and a civil engineer from France. He's he actually proposed this particular concept, that is reinforced earth concept, in 1973. So in this concept, it's very simple. So when we try to use some reinforcements in the soil, so we can reduce the deformations. So that is all about this particular concept. So this is what you can look at this. Okay, so we have a reinforced soil, and even if you are applying the weight from the very huge car, something like this, where we can see very less deformations are present. And there's a beautiful story behind this. Okay, so you can just look at the animation I have tried to show here. So these things, like this clip art is showing, like, he went to a beach one day with his children, and they were playing with sand, and they were making some pyramid with the sand, and they were jumping on that. Then what they did is, they took some branches of trees, and they tried to insert them in the pyramid, and then they started jumping on the pyramid. Then he was just observing all these things. Then he was very much surprised, because when they're jumping on the pyramid, we using these tree branches, so he could able to see that the the sand was not deforming too much. Okay, so he tried to see that. Okay, so the comparison between before the tree branches and after the tree branches. So that is what he tried to compare, and he was surprised because the deformations were very they varied too much. So earlier sand had a lot of deformations, and later part when uh, they reinforced with the tree branches, then the deformations were very less. So he understood that, okay, if we try to insert some reinforcements in the soil, similarly like concretes, and then we can actually reduce deformations with very high magnitude. And also we can increase the stability of any kind of structure. So that's what he actually started started thinking about this. And from that point of time, many innovations happened and many products came into market. And in a present day, we are actually using a lot of these products, so geosynthetic products in various applications. And as I said, when you look at the history of reinforced earth, okay, it's not a new technique. So because as you know that in presently, even in today's day, also in rural, if you go to the very remote places of India, in rural places, you can see that many houses are built using the material which is uh, you know, um, mixed with some fibers. Okay, so these fibers are taken from the fields, agricultural fields, and they try to mix that with the soil, and they construct their houses using this soil. Okay, so this is a very common thing. Be very surprised because they have built most of their houses using this type of technique, reinforced earth technique. So where we can see that the natural fibers are used and they are mixed with the soil, and they have effectively deployed in the construction of their houses. Okay, and in fact, this is always my best slide because you can see that. Okay, so as a human beings, we are well, educated, and we are actually more technical. Now we are trying to do so many things. But when you look at this animal, this a beaver, so it constructs its own house using these tree pieces. So you can look at this, how it actually construct its house, especially in the water bodies. Okay, and it brings a lot of tree branches and it collects them. It also brings some amount of soil. It takes the help of some amount of soil, and it tries to build its own house, its own net, especially in the water bodies. Okay, so that's what we can say that it's a best civil engineering, best civil engineer. Okay, so because of these things, where you can look at the innovation by the beaver. Okay, and some history. Okay, so again, when you go back 3,000 years ago, especially the Gigaratas of ancient Mesopotamia. So there, this Gigarata was almost 80-meter tall, which was built in almost 3,000 years back. And this Gigaratus was built with the clay bricks, which are reinforced with the reed grass. So this is a reed, so which is basically a name of the plant. So this reed grass were used, and they were reinforced with clay. Okay, and clay reinforced with reed was used for the construction of clay bricks, and these clay bricks have been used in the different layers with some spacing 0.5 meter to 2 meters. And when you look at this, of course, now there has been a lot of settlement of this Gigaratus. Now it is somewhere near 38 meter to 40 meter, where initially it was around 80 meter tall. But what we need to appreciate here is almost 3,000 years back. So they actually thought of using the reinforced earth technique. In fact, even if you consider the Great Wall of China, in Great Wall of China also we have the concept of reinforced earth, especially on the western China side. So because they have built this for the eastern side and the western side. So in the eastern side, they have used the bricks and the chiseled stones, but whereas on the western side, the clay with the rammed earth with some tree branches have been used. Okay, so the clay is again mixed with some tree branches, which has been a combination of reinforced soil, and this has been successfully used in the construction of Great Wall of China on the western side. Also, we have something called as adobe bricks, and which is again used almost 7,000 years BC, and in fact, it was first used in Morocco, which is a country in Africa. And in fact, now also many people are using these things, and slowly it has been modified. Okay, so now this adobe bricks has been modified, and it has been used as you know. Basically, it has been used as compressed soil blocks or interlocking soil blocks. Okay, so some improvements has been there in this particular thing. Okay, and now let us look at the mechanism of reinforced earth. Okay, so how we have what exactly is going to happen in the reinforced earth concept, because we have seen some history. Okay, so this has been used very effectively from so many years, but when you look at the mechanism, what exactly happens between the reinforcement and the soil, and how we are getting better stability, and how the deformations are being reduced, so that we need to see. So when you look at uh, the concept here, especially the delta V, if you consider with the reinforcements and the uh, unreinforcements case, the delta V has been different in both the cases. Here the vertical deformation, so delta V, if I say it as a vertical deformation, here it is too little on the higher magnitude, but whereas delta V in this case is of the lesser magnitude when you compare this with the reinforcement case. So that can tell you that, okay, so these are the reinforcements used here. And if you look at this, the deformations have been reduced due to the reinforcements. In fact, you can have this simulation using the experimental setup, especially with respect to the triaxial test setup, or maybe you can also try with UCS setup, where we can try to compare both the reinforced and unreinforced case. Okay, Nazim, am I audible?
Yes,
Nazim?
you are audible.
Yes, audible.
Okay. Okay. Now, then what about the fibers we use? Okay, so there are two types of orientation of fibers we try to use. One is ODFS, that is oriented distributed fibers, so where we use the planar fibers, whereas we have the randomly distributed fibers. So in the randomly distributed fibers are like, we have polypropylene fibers, Racron fibers, or maybe basalt fibers, and some people, they have used some fibers like coir fibers or jute fibers, where they have tried to do a lot of research. In fact, one of my friend Mohit has also worked in fibers which are orientally distributed in the soil. So the other example is planar distribution. Okay, so where we have the planar reinforcements like geogrades, geotextiles, even in fact geocells, which are basically planar in nature. Okay, so what is the interaction here? So what exactly is going to happen? So when we have the soil particles, understand that these are the soil particles, and from these soil particles, the normal pressure is going to be applied on the reinforcement, and there is going to be a frictional force which is going to occur between the soil reinforcement particles, means soil particles and the reinforcement. Okay, and when you apply the pull-out force, then there is going to be a passive force, and due to that passive force, you are going to have the better resistance. Okay, so that is what the main idea behind all this reinforced earth concept. And in fact, in FSWA manual in volume 1, FSWA NHI 10024, so they have given in detail about this interaction and all. So one can refer that manual for more details. Okay. Now coming to the most important part of our lecture, so that is the types of geosynthetics. Okay. Now we have seen about the need, why the geosynthetics are required, historical background, mechanism, what exactly is going to happen. Now we come to the actual picture, that is the geosynthetics. First, we'll look at the types, which geosynthetic products we have. So there are two things. One is natural and man-made. In the natural, we have coir and jute textiles. In man-made, it's like geotextile, geogrid, geonet, geocell, geomembrane, geodrain, geofoam. And we do have some special type of geosynthetic products like geosynthetic clay liner, geosynthetic erosion control mat, and prefabricated vertical drains, PVDs. Okay, so these are the few types of geosynthetics, and we'll see one by one in more details. So these are the natural geo synthetic products, so which are basically called as coir. So it's basically fibers which are coming from the coconut. Okay, so where we can see that these coconut fibers are being used especially for in manufacturing of oven and non-oven coir textile. And we can also see that, you know, oven geotextile, non-oven geotextile from the jute. So this is a jute which is basically obtained from the plant Corchorus olitorius, and this is the plant. So from this we obtain this jute, and from this also we obtain the oven and non-oven. Oven and non-oven means oven we are going to stitch them properly, okay, in a proper sequential manner. But non-oven geotextile or the non-oven jute textile is randomly stitched or randomly, you know, punched with some needles. Okay, so this is what happens in man-made geotextiles, like which are products more stronger than the previous one, and this is more do look at the coir and jute, so they are going to decompose or degrade with the soil. But here, you know, we have own geotextile which is being used for different functions. I'll come to the functions in later part. Okay, so this is how it looks. Oven means we are going to stitch them properly. We are going to stitch them properly with some you know, sequential manner like this. If you look at the SEM image of this, so this is how it looks. So each thread is called as yarn, and every yarn is properly stitched. And this is a non-woven geotextile. Non-woven geotextile, basically they come in thin and thick non-woven geotextile. Okay, so the thick non-woven geotextile is used for drainage and cushion. Thin non-woven geotextile is used for separation and filtration. Okay, and this is how they are being oriented. They are very randomly oriented, so they are not in a proper way. So these are geogrids. This is a uniaxial geogrid, biaxial geogrid, and the triaxial geogrid. Okay, and this is especially used for retaining walls, where you are going to expect the push action from the retaining facing. So where you can have these uniaxial geogrids. Biaxial geogrids are basically used below the this footing. And even recently, these triaxial geogrids have been introduced from by Strata, even from McAfee, which can be used for roads upgrades. Again, in the geogrid, we have two types. One is knitted, the other one is welded. Okay, so the knitted geogrid looks something like this, which are being knitted, and welded is at the joints we weld the nodes. Okay. So we have the geonets. So geonets are basically looks like this. So geonets are, they are used for especially for drainage. And here we have two ribs which are completely at different planes. and these ribs are going to act like a check dams. So that's why these are the best suitable products, especially for drainage applications. Then we have geocells. So geocells are very easy to transport, and we can fill any material in this. We can go with some gravel. We can also fill with some stone aggregates. And these pockets, when we are filled, they are going to have much stiffer, much stiffness, which is best suitable for roads upgrades. Even in container yards, also we can use them. Okay, so even we can use them for the slope stability. When you are going to use them in the steps, in the slope stability also, they are much effective. Okay, so geocells are basically used for the, you know, spreading the loads to the larger area, especially for the sub, they are much suitable. And we have something called as geomembrane. Geomembrane is used to contain the liquid or solid, especially in case of canals, to contain the liquid. In case of landfill, to contain the solid waste, we use these geomembranes. In fact, these geomembranes comes with the different thicknesses, and they comes with the different types of materials. For example, the geomembranes can be we can have the geomembranes of low density polyethylene. We can have a geomembranes of high density polyethylene. Okay, so it again depends upon the need of a client or need of the function, need of the project. Based on that, we select the thickness and we select the type of the geomembrane. But these are highly impermeable materials. Okay, so they are highly impermeable, and also they actually contain some liquid and solids. Okay, so these are geodrains. Geodrains are used behind the retaining walls. In the earlier days, we used to have chimney drain, which are basically made up of stone aggregates, where we have a lot of space for the seepage of water. But in recent days, we have this geosynthetic product where we use geodrains for the better drainage of the water behind the retaining walls. Uh, Again, in the case of retaining wall, instead of uh, you know uh, backfill soil, we can use the geoforms. Okay, so geoforms are basically they are a very lightweight material, and they make the structure very flexible. In fact, you can use them as a backfill in the retaining wall. The main idea is when we when we actually determine earth pressure from the backfill, the earth pressure is going to be very less for this, because when you take the unit weight of the geoforms, that is much lesser compared with the soil, and because of that, whatever the earth pressure you get, so that earth pressure is going to be very less. Okay, so that is why the geoform becomes much advantageous. Geosynthetic clay liner is being used in case of landfills. It is a very interesting formation where we have two non-woven geotextiles, and in between two non-woven geotextile we have the bentonite. And this bentonite, if it comes in contact with water, it tries to swell. Okay, so it's like self repairing mechanism. So that's one of the major advantage here. And this is where we use below the geomembrane in the landfill. Suppose if there is some leakage in the leachate, when the leachate is going to come in contact with this bentonite, so this bentonite expands, and if there is a puncture in the geomembrane, so that puncture will be repaired by the GCL. So I'll come to that application part, so where we can see in more detail. Coming to the GC, okay, so these are the erosion control mats, geosynthetic erosion control mats, which uh, uh, we use in the slope protection works. Okay, so in the initial slides, we have seen that the slope failure has become a major issue, and where we can have such kind of options where we can have the mats for the better seepage of water, so that there will not be any further failure of the slope. Then we have something called as PVDs. So all of you, I think, know about the preloading technique, especially the pre-consolidation technique in the clay soil. So, to increase the consolidation of clay, we used to have sand drains, or even we used to have something called as sand drains along with the embankment, which we are going to construct on that, so that we increase the consolidation process of the clay. But we can have these products instead of sand drains, where these PVDs are replaced, in place of sand drains. These PVDs are nothing but they have the corrugated plastic sheet at the center, and this sheet is covered by the non-woven geotextile. So here, you are going to have much better drainage, almost the permeability equivalent to the sand drains, so that the consolidation process is going to be much faster, and the consolidation settlements are going to be much faster. Okay, so then we have a very interesting products which are basically called as geocomposites. So geocomposite is all about the combination. Okay, for example, let's say I want a separation and also I want the drainage. So in that case, what I do is I use the non-woven geotextile. So NWGT stands for non-woven geotextile. Then we have the geonet. Okay, so geonet is for drainage. Non-woven geotextile is for the separation or filtration. Okay, so we get some very special adhesives in the market, so we can use those adhesives and we can fix two products each other, and we can use them as a combine, so that we take the effect of two products, the function, we take the advantages of the functions of two products, and we use them very effectively. Oven geotextile and geonet, for example, let's say you want to use the reinforcement as a reinforcement and the drainage, then this is the option you have. The non-woven geotextile plus geogrid. So geogrid is used for reinforcement, and non-woven geotextile is again for you know uh, separation or the filtration or something like that. Woven geotextile and geodrain. So again we have a very interesting thing, like one is for drainage, the other one is for reinforcement. Okay. Now coming to the functions. Okay. The types we have seen, but all these products comes with some function. Okay, so you cannot use all the products for all the functions. We have few products which are meant for only few function. So now let us look at those functions first. Okay, so what are the different functions made by or maybe carried by this particular geosynthetic products? One is separation. Separation is one very important function, which is basically done by non-woven geotextile. Erosion control mats. So erosion control is another function, so we can control the erosion. We have the reinforcement, so we can use the products for the application of reinforcements. For example, if you look at the geogrid or if you look at the geotextile, especially the woven geotextile, so we can use them for the function of reinforcement. We can use for the drainage. We can use as a barrier. So drainage, as I said, geodrains we can use. We can use the geonets. Barrier, it is only one product, which is geomembrane. So when we use geomembrane, we can contain the liquid and also we can contain the solids. So we can also use filtration. So woven geotextiles can be used as a filtration. So this is the rubrics. Okay. So this is the rubrics where you can look at the the functions here on the x direction, and on the y direction column we have the products. So this is geotextile, geogrid, geonet, geocell, geomembrane, geosynthetic clay liner, geodrain, geosynthetic erosion control, and these are geocomposites. Now geotextile is used for reinforcement. So this green indicates suitable, red indicates not suitable. Geotextile is suitable for reinforcement. Geotextile is suitable for separation, filtration, and drainage. Geotextile I cannot use for the barrier. I cannot use it for erosion control. I cannot use it for protection. Okay. So we need to see the functions, and according to the functions and according to the need, we have to use the products. Geogrids are best suitable for reinforcement, and it is not suitable for any other function. Geonets are best suitable for drainage. Geocells are best suitable for erosion control and the protection. Geomembrane is suitable for only one function, that is barrier. Geosynthetic clay liner is suitable for barrier and also protection. Okay, so barrier can be also there even when we are using it along with the geomembrane, and it can be also used as a protection. Geodrains are used for the drainage function. Erosion control mats for erosion control. Geocomposites, fine. So geocomposites, it's up to the imagination of the engineer. You can combine two products and you can have all the functions or any of the functions. Okay, so that's why I have mapped geocomposites with all the functions. Okay, so this is how the rubrics looks like with respect to the functions. Okay, now coming to the very important part of our lecture, so that is applications. Now, applications of geosynthetics in civil engineering projects. So that is what my title of the lecture. So here I'm going to talk about different applications. One is we have the different areas of applications, so which comes under the umbrella of civil engineering. We can see about the disaster management, especially the landslides, water resource engineering, especially in case of canals and earthen dams, transportation engineering in case of pavements and runways, geoenvironmental engineering in case of landfills. In fact, shore protection is also one of the area in case of offshore engineering. So in slope protection, we can use the geocells, okay, like this. So you can look at this. They have used the geocells, and it can be used with some filled material. We can have some fillers so that we get much better, you know, um, properties. Then coming to the control mats, erosion control mats. So these are the jute mats they have used, and the left side you can see that they have used the GEC, that is geosynthetic erosion control mats, along with some soil nails, and they have also went for vegetation. Okay, so this is one of the slope protection work. And if you want to go for the natural, we have the usage of jute mats, where this jute mat is going to disintegrate with the soil, which can be further very useful for the vegetation. Okay, so we can have some growth of plants here, so where we have better vegetation, so that the soil erosion can be minimized. In fact, for the slope protection, one can go for gabion walls like this, or maybe you can talk about reinforced soil walls using the reinforcements and facing walls. I'll come to this later in more details. So these are the gabion walls, which are basically the stones which are being filled under the steel mesh, and they are much economical solutions, and also they are more sustainable. In fact, especially for the smaller heights, they are very effective. Okay, so the gabion walls can be used near the roads or near the the water bodies, which are very useful. In the canals, okay, so in the canals, bottom layer, side, bottom liner, side liner, we can have the geomembranes. Okay, so having the geomembrane, there are one a very advantage here, because the geomembrane, as we know, that it is a barrier, so it can contain some liquid. When we have geomembranes, in fact, our efficiency of canals, okay, so it's going to be very high, because of you know uh, there is no infiltration of water into the bottom liner or into the side liner. So that's very advantageous here. So that's why we use geomembranes in the canals. We can just look at this, where they are laying the geomembrane sheets on the side liners. In fact, even on the bottom liner, they are trying to lay some of the sheets. In fact, geotextiles have been also used in the earthen dams, okay, especially for the drainage purpose. You can look at this. So this is the portion what you are looking here. So this is the drainage layer. If you look at the cross section of this, so where we have the geotextile, so this is the area where you can see that a very small portion of the area is covered with the geotextile. Okay, and in northern dam also we have a lot of usage of the geotextiles. Okay, so you can look at this like which are the areas, which are the sections we use the geosynthetic products, like on the upstream side this may be a geomembrane, and on this side this can be a geomembrane under drain, and in fact this can be a chimney drain with some stone aggregates, and this can be a finger drain outlet. Okay, so here also we have uh, some applications of geosynthetic products. Coming to the pavements, okay, so in the pavements, as you know that uh, our geosynthetic products are used for so many different applications. For example, you can look at this at the top layer. Okay, so there is a separation. We can use a non-woven geotextile for a separate as a separator, and this symbol represents for the reinforcement, whatever you are seeing here. So this symbol represents for the reinforcement, and we have the another combination of reinforcement here, especially used for the stiffening purpose. And here we have the geomembrane, which is used for the barrier. Here we have another layer of geotextile, which is used for the filtration, and we have geonet, which is used for the drainage. Now you look at this conventional flexible pavement. When we talk, it's all about subgrade, subbase, base. Then we have surface layers. But when you look at the applications of geosynthetics in all these layers, between subgrade and subbase, we have geonet, we have geotextile, we have geogrid. Again, in between subbase and base, we have so many products over there. Especially when we are talking about the durability, when we are talking about the sustainability, so these are the things which we need to look for. Okay, especially we can minimize the surface settlements of the pavements surface, and we can have the much better performance, and also we can have the much better life cycle of a pavement. Okay, so that's very, very important. In fact, even in the pavement, we can use the geosynthetic products, especially the geotextile, in between the surface layers itself. So, which is called as asphalt overlay fabrics. For example, let us say this is a old pavement, and here you are going to have the new pavement layer. Okay, so already you have the old pavement layer, and above that you are going to lay down the new pavement. So in that case, what happens? Let's say if there is a crack, let's say this is a crack here in the older pavement. Then when you just lay down the new pavement, then what happens? That crack is going to propagate into the upper layer. So something like this, what you are looking at. Okay. So that crack, so the crack from the older pavement is going to transfer into the new pavement, which should be avoided, right? So that's what we do here is we can have one geosynthetic product, especially the oven geotextile is the best product for this. What we do is here oven geotextile can be placed, and you can compare this image and this image where that crack propagation has been stopped. Now the crack has not been propagated into the new layer. Okay, so this has been taken from the a very interesting paper from John Berg 2017. So you can also refer that paper for more details. And in fact, when we have the mixing of layers, let's say we have the subbase and we have subgrade. Okay, so we have subgrade and subbase. Let's say if I don't want to mix up the things, here we have stone aggregates, here we have the soil. So to maintain that separation, so stone aggregates and the soil, we need to use the product, which is basically a geotextile. In fact, when we use at the junction of subbase and subgrade, we can also have better load distribution to the larger area. Now you can see here, this is the load distribution here, the stress distribution, but here the stress distribution is to the larger area. When the stress is going to distribute to the larger area, then what happens? The settlements or the ruts are going to be minimized to the larger extent. Okay, so you can look at this is the deformation of the pavement under this wheel, whereas you can look at the deformation under this wheel. So this is almost negligible. So that is one of the major advantage here. Another example, okay, so where you can actually look at this in case of bearing capacity analysis. So as you know that this is the example of punching shear failure under the concentrated loads. Okay, so where once I use the uh, geosynthetic product at the junction between the base and subgrade, what we are really doing is we are trying to convert that punching shear failure to the general shear failure. Okay, now you can look at this. This is a punching shear failure example. Now, if you look at this, this punching shear failure has been converted to the general shear failure. So general shear failure is all about you have the well-defined shear failure surfaces, and these shear failure surfaces are reaching the ground, and here you are distributing the stress to the larger area so that you are going to minimize the settlements to the larger extent. So that's very, very important. In fact, in the pavement again, you can use the products for the drainage. Okay, so let's say there is a water logging problem below the sub base. Then in that case, below the base, in that case, what you can do is you can have one geosynthetic product like geodrains or maybe geonets, where you can drain out that water completely, and you can have the better performance of the pavement layers. So you can look at this. You can just compare this image and this image. So here we have a geosynthetic product. All the water has been drained and has been collected at the the drains which we have at the sides. So from those drains we can drain out the water. Okay, so the drainage is again one very, very important thing. So geogrids can be used for the reinforcement. In fact, okay, so we can have the geogrids below the surface layer, which can be used for the uh, you know uh, for the betterment of the reinforcement. So to increase the strength of the you know uh, pavement layers, to increase the performance of the pavement layers. In fact, you can see that these are the triaxial geogrids which have been used here, which are recently produced by very good companies in India. Okay, and again in the pavements, as I said, geotextile and geogrids, which are being used for the reinforcement, suppression, for the filtration, and for the drainage. Now you look at this. This is a geotextile which is used for this is a geogrid which is used for the reinforcement purpose. This is own geotextile which is being used for the suppression or filtration function. Okay, some examples you can look at this. Okay, so this is just on the older pavement uh, being used as something like overlay fabrics, geotextile overlay fabrics. So where you cannot propagate the older crack into the new pavement. So that is the example here, and we have the geogrids here, okay, being used as a reinforcement. In fact, in some of the examples, especially in subgrades, we have used a lot of geocells also. Okay, so to have the better uniformity in the subgrade, geocells are being used, and these are the knitted geogrids used for the reinforcement purpose, especially in the junction of base and subgrade. In fact, we have also seen some failures of runways from the Japan, from the Philippines. Even in fact, we have some case studies of India where airport runways have some severe problems. There also, you can have the geocells and geogrids for the better reinforcement and the support. You can look at this. Geocells are used in the larger extent. So these are the laying of geocells. Okay, where these geocells are being filled with the stone aggregates, and these are the construction of runways. And this this is basically very, very useful to prevent the slippage problem when the when the planes are landing and we have the problem of larger impact. To avoid those things, we can have this kind of reinforcement, especially coming from the geocell and geogrids. Okay, so we have you can just look at this. These all things are geocells, what you are seeing here, and the filling process is going on. Okay, so this is being done in Mexico airport. So all of you know that Mexico is a place where we have a lot of problems with expansive soil. We have the Mexico clay, which is a very popular clay where we have very weird properties of Mexico clay with a very large liquid limit, large expansiveness of the soil, with a very critical shrinkage limit and all other things. So there, we can have such kind of sustainable products, and we can have a better improvement in the projects. Okay, so then, after they lay down these things, then we have the geotextile. Then after that, again, one more layer of, GSPs, and they do it very nicely. Then we have the next problem. So that's what we were talking about, the landfills. Okay, in the landfill, as I said, the disposal of the landfills. So the disposal of the waste in the landfill is a very important thing. We need to follow engineered landfill, sanitary engineered landfill concept. So according to the CPCB, when we have more population, when the waste generation is very high, basically if you compare, like we human beings, the per capita generation of the waste is almost 1.5 to 3 kgs per day per capita. And when we calculate with respect to the number of people living in that area, especially when the population is more, the waste generation is going to be very, very high. So we need to dispose it properly. And this is a leachate what you are looking at here. So this leachate, if it is contaminating with the water, then it's a big problem. So this is also one of the study done by one of my a very good friend, Vemula Anand Reddy. Recently he defended his thesis. you know these contaminants, when we are mixed with the groundwater, then of course they are not meeting our drinking water standards, and in fact we need to avoid that. Okay, so we need to avoid that. To avoid that, we need to have the liners for the landfills. So this is the best way of disposing the waste. This is the best way of disposing the waste. For example, you can look at this. We have lot of layers, we have lot of liners, I can say, here. So let's say this is the existing soil, and this is the geotextile, this is a geomembrane. Then we have the drainage stone here, and above that one more layer of geomembrane. Then this is the waste. Okay, what you are looking here, this is the waste, and this is the portion of closure. In the closure also we have the soil. Okay, especially the sand is more preferable. Then we have the one layer of geomembrane, another layer of LDP geomembrane. Then we have geocomposites, especially a combination of non-woven geotextile and along with some geonets, and also we have the soil, and again at the end we have the vegetation at the top. Okay, so this vegetation is much needed because of two things. One is aesthetically it is very pleasing, and also we can actually use that place for the recreational purpose. For example, you can make it like public parkings, or maybe public parks, or maybe gardens or something like that. So where this is very, very important thing. Okay, so these are the liners. Okay, so the liners are something like this. For example, this is a example, the existing landfill or the waste. We have the base course layer, which is basically a sand. This is a geosynthetic layer liner. We have a geomembrane. This is non-woven geotextile. Then this is a leachate collection system or the drainage layer. Then we have non-woven geotextile. Then protection layer from the residue. So this is basically a gravel layer. Then we have the waste at the top. Okay, so this is the best examples of the liners. And this is a closure. So closure is something like this. At the top, we have the contaminated soil, then the coarse layer, support layer, and then geomembrane, geomembrane. Then we have non-woven geotextile, drainage layer, non-woven geotextile, base layer, and all other things. Okay, so this is how the liners actually looks like. Few case studies I'll try to show you here. Especially this is from Valencia, Spain. And these are the liners. Okay, so this is geotextile, this is a geomembrane. So waste is being dumped here. So this is the liners which are basically used at the bottom, at the sides. So where you can see that a lot of waste can be dumped here. So on the liner and the sides, geomembrane liners are being used. First, we prepare the things. So these are the the pipelines for the gas collection. So methane gas is being collected here. For a few examples, you can look at this. Okay, so this is the hazardous waste collection landfill, and these are the regular MSW waste collection landfills. And in fact, this is one of the very near to Surat. We have Vapi. This is first India's vertical landfill. Okay, so they have used reinforced earth retaining wall, which is also popularly known as MSC wall, for the increasing the capacity of landfill. Because this is a landfill we have, and this is MSC wall. So the reinforced earth technique is used here and also here. So they work in different phases. So this is the existing cell, so which is already being filled, and you can look at the other cells here. So the completed landfill looks something like this. Okay, so which is very pleasing and which is very useful for the further use. Also, you can have gardens here. You can have some parks here for the uh, different purposes. Okay, so this is one of the, so whatever you are looking here, so this is a completed uh, landfill in all the aspects. Okay, so in below this, if you just do the investigation, you'll find all the waste and other things. Now coming to the very important part, so that is MSC walls, or the reinforced earth retaining walls. So there are different types of reinforced earth retaining walls. Okay, again, these are basically used in case of approach roads, in case of flyovers, in case of you know uh, protection for the slopes. There are many applications out there. Again, there are different uh, you know um, types are there. One is segmental precast panel walls, something like this. These are the modular block walls, and this is wire faced MSC walls. Okay, these are back-to-back MSC walls. I think most of us we have seen these type of walls, especially in the underpasses, in the flyovers, especially from Mysuru to Bangalore. We have a expressway which is coming, and which is the construction is going on, where you can see more almost 40 to 45 reinforced earth retaining walls, which is basically used for 10-lane expressway between Mysore and Bangalore. Okay, so this is one of the very advantageous MSC wall, and in fact, in Surat itself, we have seen that a lot of flyovers, and all these flyovers are, most of the places, all these flyovers are constructed with this particular technique, reinforced earth retaining wall technique, or the MSC wall technique. Okay, uh, okay, fine. So these are some other types. Uh, as I said, even in fact, our own Ahmedabad and Baroda highway, NH48, is in that stretch, we can see a lot of modular block retaining walls, and this is basically reinforced with geogrids at the back. At the facing, we have one particular facing panels, and at the back, we can have geogrids or geotextiles or geosynthetic straps. So there are different things. Just now I mentioned about this. So this is the MSC wall, which is basically used for the landfill. So in the WAPI, so the both applications are there. So one is retaining wall application, geosynthetics are there. In fact, in the landfill, the geosynthetic applications are there. So in fact, Surat Bharuch highway also, we have modular block retaining walls, earth retaining walls, which is basically constructed by strata. These are the reinforcements. This is the facing panel. We have a sub-base soil here. Okay. Then we have something called as PVDs. Okay. So PVDs are basically called as prefabricated vertical drains. As I said, to increase the consolidation process. Okay. So to minimize the time for the consolidation, we use these PVDs. So this is a sequence of construction of PVDs. Okay. So you can see that how these PVDs are being constructed. So we have a lot of PVDs which are being constructed here. Okay, especially in the very soft clays, especially in the expansive soil, we go for this technique so that the expected settlements are being happened before the actual construction of the project. Okay, so these are vertical PVDs and horizontal PVDs. Okay, these are some PVDs which are being installed. Okay, and especially for the shore protection. So whatever the problems I have mentioned in the initial slides, here we have the solutions. The problem of soil erosion in the shore can be protected by sandbags, which are basically geotextile sandbags. Okay, and in fact, we can also use gabion walls. Um, so this is one of the example of geotubes, which are basically geotextile made up of geotextile with some pressure inside. So this is geotube, and these are the sandbags used for the slope protection. So this is the best examples you can see here. Okay, so this is a few applications we have seen. Now let us look at the advantages. Coming to the advantages of geosynthetics, basically they are less sensitive to the environment because they are basically a polymeric products, but they don't actually harm the environment. And we have the improved performance, and they are more sustainable, and especially they are cheaper in product cost, transportation, and installation. Okay, so they are much cheaper because when you look at the prices of so many products like geotextile comes around 12 to maybe 20 rupees for per square meters, and in fact geogrids is almost 50 to 200 rupees. Again, it depends on your specification. So if you want better tensile strength, then the price is going to increase. A geomembrane comes with some little higher price like 300 to 600 rupees per square meter. Geocells is almost 100 to 400 rupees per square meter. So like, the cost is much lesser. In fact, okay, so you need to actually compare with the another solution. Then if you are making it very economical with respect to the safety, sustainable, then this is much suitable product. Then we can save the space. Installation is very easy. Then the construction quality is much better. Heavy equipments may not be necessary. Okay, and it is very consistent with the wide range of soils. We can use these products for any type of soils. Then we can save a lot of money in so many projects. Okay, for example, I can show you now. For example, let's say you compare the thickness of the compacted clay liner with respect to the geosynthetic clay liner. Compacted clay liner, you require like something 0.75 meters, but geosynthetic clay liner, you required of 0.013 meters. So it's almost 13 mm thickness you have, which is replaced by the 0.75 mm, 0.75 meter thickness. So there is huge, space, saving in the space. So that's one of the major reason. And in fact, when you compare the conventional retaining wall with respect to the reinforced earth wall, it's one of the paper published in Sustainability Journal of ASE, authored by Rajiv and Professor Krishna Reddy. So where you can see that global warming of cantilever retaining wall with respect to the MSE wall, which is very less. Acidification is also very less. Okay, so all these things you can, smog produced is very less. So all these things are being studied in using CIMAPRO tool, and also you can look at the human health, effect on the human health, effect on the ecosystem, effect on the resources of cantilever wall and the MSE wall. So already it has been proved from so many researchers that reinforced earth technique is one of the most suitable and most sustainable technique. In fact, in RM Koiner, in his paper in 2000, he has also mentioned that the cost comparison of the reinforced earth wall with respect to the height, okay, you can see that MSC wall with geosynthetics are much economical with respect to the gravity wall. And that is one of the reason we are seeing a lot of these MSC walls nowadays as a replacement of gravity retaining wall or the cantilever retaining walls. Even we can minimize the based on the Girard and Norway in their paper, they have clearly mentioned that how much thickness can be reduced of the flexible pavement when we insert the reinforcement. Okay, so this is the H naught without reinforcement. This is the H with reinforcement. So that is the reduce in the thickness of the pavement when we insert the geosynthetic products. So that's one of the very important thing. And just in the last 5 minutes, I'll try to cover a few case histories of applications. So this is a expressway in Philippines being conducted by 10K Geosynthetics by Asia. So this is the application of geotextiles in the low volume roads, and this is again another application of geosynthetics in Malaysia. So you can see that geotextile is used. So actually they have constructed the embankment, and above that there is a geotextile, and above that there is a filled material, then the compaction is done, and finally they have the completed product, something like this. Okay. Then we have road-based reinforcement works, especially for Philippines, in the Philippines, geotextile. Okay. And we have the proper filled material, then the compaction is being done. And even in fact in the capital city of Philippines, in the Manila, they have the slope protection work using the geocell. We have oven geotextile, then geocell. These geocells are filled with some soil so that we have better vegetation. So you can look at the vegetation here. Okay, so in fact in 2014, along with Professor Raj Gopal, okay, we had this particular project. Okay, we went to this particular project. So it is a outer ring road project by Ashoka Buildcon in Chennai. So they used fly ash as a backfill for the reinforced earth wall, and the modular blocks were used for the facings. Reinforcements were geogrids here. So these are the geogrid reinforcements used for the reinforced earth retaining wall. Okay, so these are the modular blocks which were produced at the site. Okay, in fact, the one major project by McAfee Environmental Solutions for the Sikkim. Okay, so this is the airport, construction of new airport at Pakyong, Sikkim. So this is actually done in the complete hilly area. So there they have constructed the artificial land using the retaining walls by gabion walls, and above those walls they have actually constructed the runway, also the airport, and now it is being functional, and it is one of the major major project of McAfee. So this is a proposed runway. Okay, and this is the this is actually few difficulties what they faced. This is a very lush green area, and here they had different solutions in fact, but they came up with some solution with respect to the gabion wall. Okay, and they have actually constructed almost 81-meter height gabion retaining wall. Okay, and they have done some numerical analysis before actual implementation using their own software MaxStars. This is the some pictures of construction. Okay, so they have used a lot of geogrids, and this is a retaining wall. You can look at this. So this is a retaining wall of gabion wall, and this is a completed runway of Pakyong. Okay, so this is a completed runway. This is basically by the McAfee. It's their very proud project, in fact. Okay, so I'll just give you some information about geosynthetics at the end. Okay, so initially the number of publications in the area of geosynthetics were very, very less. So this is the global number. Okay, but now when you look at the increase in the publications, in fact, the recent publications are much higher. It's up to 2015. So there has been a lot of increase in the publications with respect to the geosynthetics area. So that actually tells you that how best these products have been deployed in various projects, and how best these products are giving us the results. Because there has been a lot of research being carried out on this. In fact, in India also, we have a lot of research being carried out in many IITs, even in NITs, on this particular product. Okay. Okay, so especially those who are students here, in fact, I have my own students from NIE and few students from SVNIT Surat. For them, there is a good news. There is a society called International Geosynthetic Society. So the membership is free. You can become a member. You can visit that website and you can become a member. Okay, and you'll get a newsletter, and also you'll get all the updates of the projects which are being carried out across the globe in the area of geosynthetics. Okay, then there are IGS chapter websites are there. Geosynthetic Institute is there. If anybody is interested, then they can become a member. Geosynthetica is a very popular journal in the area of geosynthetics. Usually, I prefer these are the best books in geosynthetics. One is by SASP, Geosynthetics in Civil Engineering, and the other one is Geosynthetics Engineering by Professor Sanjay Kumar Shukla. Then we have uh, who is a very pioneer in geosynthetics, Robert Koiner. So he actually wrote very interesting books on geosynthetics. The latest version is this. We have both volume 1 and volume 2. Okay, so that's all about geosynthetics. I hope all of you enjoyed my talk, and thank you everyone. If you have any questions, then I can take few questions. Okay, thank you. And I thank Professor Solanki, Nehal Bhai, and Hitesh sir for giving me this opportunity. Thank you so much, sir.
Thank you, Anand, for explaining very lucidly about all the applications of geosynthetics in civil engineering projects. If anyone wants to ask anything, then he or she can write in the chat box or can unmute and ask one by one questions.
Hi, Anand.
Any question? Yes, Mohit, you can ask.
Yeah, Anand.
Yes,
I
Mohit.
have a quick query. You have
Yeah.
shown one slide of PVD. Like, no doubt you have not covered the calculation part of something, but like if we calculate the time required for consolidation. So
Yeah.
for the 3D consolidation of PVD also, in I don't remember the exact name of book, but in majority of the books they have given equation for that T50 4R squared divided by CV. So
Yeah, exactly.
that 4R is that for the 3-dimensional. That's why in 4 directions. So PVD is a strip. So how
Yeah.
we can consider the all-dimensional flow? Because this R is the drainage path. If we consider a sand drain, then it will have a circular diameter throughout
Yeah.
the. But in case of PVD, we have a strip. So it is having one-dimensional long and it is having a very short direction in one side. So
Yeah.
we can consider that 4R. If you can.
Yeah. So yeah, you are saying that when you look at the configuration of sand drains, especially we consider that 4R, which is basically an effective area for the
Yes.
drainage, but these are the negligible radius we have, if in fact, so they are coming with a strip. So basically, especially for PVDs, the calculation is very different. We don't follow that 4R concept here. So the calculation is very, very different. But, when it is being implied, okay, so the permeability when we consider, okay, so the permeability or the drainage time for PVDs and sand drains are much, much similar. Okay, so based on that, these products were much effective. But coming to the concept, what we followed in the sand drains, it's not applicable for these PVDs.
Yes.
Okay, so that is what I can say. Okay, but there are few literatures. Actually, we can look into some literatures. So maybe we may get some more information about this.
Yeah.
Yeah.
Actually, same equation I have seen in calculation of PVD also. That's why I got some confusion.
Yes, yes, Mohit. Yeah, you're right. Okay.
Okay, thanks.
Thank you, Mohit.
Yes, Mohammad Soeb Hussain can unmute and ask his query. Shoaib Hussain. Okay, there is one question in chat box. What areas would recommend for research with regards to highway engineering in this topic, since a lot of work has been done?
Yeah, yeah, you're right. So already many of the research is being carried out, especially in our own SVNIT, especially many of the students are doing a lot of work, and even in IIT Madras, IIT Bombay, in fact, even in IIT Delhi, in fact, even IIC Bangalore also, people are doing a lot of work in the area of geosynthetics with respect to the highway engineering. But what I recommend is, the best part, what we can do is you can try to take up few case studies. Okay, you can try to implement the geosynthetic products, okay, with some live projects, and you can also do some numerical studies by using various numerical techniques, and you can try to compare both the numerical and case study or the live projects which you will be doing. And one more suggestion what I can give is, we have after PMGSY project, we don't have much scope for the improvements of rural roads. Okay, PMGSY project was amazing. Pradhan Mantri Gramina Sadak Yojana, under that project, so they have done a lot of work in the rural areas. But as a researchers, what we can do is, especially for low volume roads, okay, especially for low volume roads, how best we can use these geosynthetic products, okay, like geocells. If I filled with some stone aggregates, and when I have few thicknesses of soil, and if I compact it, then what amount of traffic it can bear, and will it be very effective in case of low volume roads or something like that. So those kind of works can be carried out. Okay, so you can consider few stretch, and you can try to implement that. And as I said, the pricing is also very, very less, and you can try to procure these products, and you can do some field studies, because IIT Bombay, IIT Madras, so they have the geosynthetic lab, and they are doing a lot of laboratory testings. Okay, and these things are already proved with respect to the laboratory investigation. But what we need to do is we have to do some field studies which are much required. Okay, for example, as I said, low volume roads, when you implement that geocell, so you can also do some field CPR, you can also do some deflectometer test, and also you can have some other tests with respect to the transportation engineering, and you can see the improvement in the soil performance. So those things can be done in the highway engineering, I can say.
Okay, thank you, Anand. So, as there are no questions, so I would like to ask my colleague Bhumi Kamdar to give a final vote of thanks, and then we'll end this session.
Nazim, I think one more question came in chat box.
Sir, I have a question to ask you. Can I?
Okay, you can ask Manish.
Myself, Manish Singhal. Sir, what are using
Manish, your voice is not clear.
Okay.
You can write your question in chat box. Anand, there is one more question. How we get free membership in International Geosynthetics Society?
Yeah, this already I mentioned. You can go to the official website of IGS, International Geosynthetics Society. So there, there is a link for membership. So there you need to select for student membership. Okay, so if you are going with the student membership, then it is free. But if you want the life membership of IGS, then there is some fee. So you need to just go through that website. So you'll get more details about that.
Okay. Yeah. Yes, Manish, now unmute and ask your question. Manish?
Otherwise, he can also
write in chat box.
Yeah.
Okay, guys, on behalf of IGS Surat Chapter, I thank you to Dr. Anand Hulagabali for providing an excellent lecture. It is very informative and useful to the students as well as professionals. Thank you, Anand.
Thank you, sir. Thank you, sir. Thank you, Nehal, sir. Thank you, Najim.
Thank you.
And I
Thank you.
thank all the students, all the friends, and all the
Okay.
professors who has attended this. Okay.
Thank you. Thank you
Thank you,
all for joining. And one more thing I would like to mention, that these webinars which we are conducting is just for the knowledge sharing purpose. So we are not providing any certificates or any attendance link. So kindly bear with us in that. Thank you all for joining. So with this, we'll end the session over here.
Okay, bye.
Thank you all for joining. Thank you, Anand.
Thank you. Thank you.